Hi there, this is Manish, and in this series, we are going to look at how computer works from the very ground up. So, welcome to the very first episode of the series. In this episode, we'll be looking at the story of two friends. These two friends used to live very close to each other, and their house was separated by, let's say, some 10 to 20 meters distant, and they had window facing each other. So during the night times, these two best friends used to talk to each other, but because their parents didn't want them to wake up till late night, they wanted them to sleep at 9 p.m. So sleep early, wake up early routine. But they don't want to listen to their parent. They want to keep their conversation going even during the nights. To address this problem, these two kids wanted to come up with some solution using which they could talk with each other. During the night times, waving hand would be difficult. They can't see each other, and it's kind of difficult to convey the message. So they thought, what if we could use a flashlight? Yeah, this is obviously a flashlight. Not so good drawing, but yeah, this is a flashlight. And these two friends agreed that if you move the flashlight in this way, then it would be A. So turn on the flashlight, move it like this, and it would be A. For O, just to make a circle using flashlight, and it would be O. So that's how they decided to keep this code of conversation between themselves. But soon they realized it is very difficult to keep up while talking to each other this way, because some words have more letters in their word, and keeping track of what it was said earlier was difficult, and hence figuring out what is going on in the conversation, it's like very difficult and also not very efficient. So they decided to come up with a new approach where they, instead of moving their flashlight like so, they decided to use blinks. So one blink would be A, two blinks would be B, and so on. So three blinks would be C, and going like the same way would be for D, E, so on. So let's say now this friend, wanted to say hi to friend B. So for this, what he had to do is to turn on torch and do 8 blinks, and then some pause, and then again 9 blinks. So 8 blinks plus 9 blinks, total 17 blinks it would be required to say hi from this person to this person. Now, let's say this person wanted to say, how are you? Now the problem arises, because if you have to say this to your friend, you have to do like more than 100 plus blinks just to say, how are you? Imagine replying something with even longer sentence, and then you have to reach like 500 blinks. So this method of communication also kind of inefficient for these two friends. They wanted to come up with some new rules in which they could communicate with greater efficiency. And they were lucky enough that there is something called Morse code. Morse code was originally developed by Samuel Morse. So yes, this Morse code was under the named from the same person. So this Morse is how the Morse code is named after. It was invented in 1830s, and it soon became a very popular way to communicate the messages in code. So Morse code comprises of dot and dash. This is dot, this is dash. So in Morse code, if you have to write A, then it would be dot dash. For B, it would be dash dot dot dot. C, it would be dash dot dash dot. and so on. So getting inspired by this dot and dashes from the Morse code, these two friends decided to use the flashlight in the same way. So they decided that if they turn on the flashlight for 1 second, then that would be equal to dot. And if they turn on the flashlight for 3 seconds, that would be dash. Now, so if they have to say A now, they would just do one blink and then pause for a second and then blink for 3 seconds. And this would be equal to A. Now, this is efficient than before. But there are some rules of Morse code. The rules of Morse code is, it is kind of a time dependent. So let's say this dot, if your flash is for 1 second for this dot, then for dash you have to flash for 3 seconds. And between dot and dash in the same letter, when I'm saying same letter, I mean for A we have dot dash. So this is a single word, single letter with dot and dash, and so in between there would be a gap of 1 second. Now, if we have to say A, B, or let's say we have to say hi. So for H, we have 4 dot, and for I, we have 2 dot. So now, the gap between these dot would be 1 second, because these are part of single letter, and this is different letter I, and this would be having a gap of 1 second. But what about the gap between these two letters? The gap between different letters would be 3 seconds. And the gap between two words, let's say we want to say how are you. So if we write the Morse code for this, and then if we write Morse code for this, then the gap between these two would be 7 seconds. For convenience and saving time, while reading this Morse code, we say dip. For dots, for the dot, we use dip, and dab. This is dip, and dab for dash. One more thing is that while using dot for the same letter, which is the end dot for the same letter, we use, instead of dip, we say dipped. Dip for last dot in same letter. So we show this first rule, where dot is of 1 second, dash is of 3 seconds, gap between dash or dots, or either dots and dots, dash or dash in the same letter, it would be 1 second. The gap between dash or dots, or dots or dots, dash or dots would be 3 seconds if there would be 2 letters. I mean, the gap between the Morse code of 2 letters would be 3 seconds. And the fifth rule is that for the gap between 2 words, it would be 7 seconds. Now, important thing here, the time here we used 1 second is actually not second. It could be any time. We can replace it with unit, 1 unit of time. So if some person decided to use 10 seconds for dot, then they would just have to simply use 30 seconds for dash. That's the rule. They don't just have to use 1 second. They can even make it like 0.01 second for dot, and then 0.03 seconds for dash. So that's how it works. So this is the rule of Morse code. Now, coming back to the story of the two friends, where one of the friends sent hi in a Morse code to the person B. This person sent 4 dot, some space for 3 seconds, and then 2 dots. So this was the code sent by person A to person B. Now, if you have to convert the alphabets into Morse code, it is quite easier because you have the table for all the alphabets, and you can just look at them and just write it. But what if you have to decode this back to the alphabet? So to make the task easier, we have something called Morse code tree. So the Morse code tree looks like this. So every time you go to the left of this tree, you add one dot, and every time you go to the right of tree, you add dash. So the first single dot represents E, E being the most used alphabet in any textual material in English. So to keep it efficient, single dot would be E, then T for dash, single dash. Now, if you go left from E, the left would be dot and the right would be dash. And similarly, for T, if you go to the left, dot and then dash. Now, dot, dot, that means two dot. Two dot would be I. Dot and dash, it would be A. Dash dot, it would be N. Dash dash would be N. So if you go down the same way, we have the tree like this. And then again, going down, left, as I said, would be dot, right would be dash. Yeah, so this is going to look weird now because of lack of space here. So this would be H, this would be V. And so on. So here we have two alphabets in this layer, and then here we have four alphabets, and again here we have 8 alphabets, and here we will be having 16 alphabets. So if you sum up all these, then you would get 30. So 30 would be basically comprises of 26 English alphabets plus 4 accent alphabets like this. Two more would be here. We didn't get the space to write it down there, but it would be like this. These two and these two would be 4 accent alphabets. So with this Morse code tree, it would be very simple for you to decode this Morse code back to the alphabets. For example, you have four dots here. So dot, 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 4 dots. H, this one. Now 2 dots. As I said, for dots, we always go to the left. So dot and then again dot, left. Here, 2 dots would be I. So this is I. So this was the original message sent by this person to you, this person B. And that's how you decoded it using Morse code tree. Now, there is a fun fact. SOS. So in your phone also you have seen this SOS. This is emergency signal. So the fun fact is we don't have any abbreviation for this, with no abbreviation for SOS. Some people say it is for save or save because it was used by sailors very early, like 100 years back. So that's what SOS stands for, but in reality it is not. SOS is basically related to Morse code. So if you're converting SOS into Morse code, it would be 3 dots, 3 dash, 3 dots. So if you go up, you can see S here. This is S, this is O. So 1, 2, 3, 3 dots would be S, and 3 dashes would be O. So this SOS signal is that was used before and also now comprises of 3 dots for S, 3 dashes for O, and 3 dots for S. Okay. Now it was used because these 3 dots and then 3 dashes would be easier for any person to learn, and it would be very difficult to get confused with this because, as you can see, 3 dots, 3 dash, 3 dots again. So it was easier for people to remember. That's why it was decided to use SOS for signaling emergency, and it was not abbreviated for save or save or anything like that. But it was used for those kind of purposes, I said. So this is a single word. There is no abbreviation of this. This line above SOS represents this is a single word. There is no other abbreviation for this, and the reason why it is so commonly used even these days, because it was originally came up from the Morse code, where SOS writing is very easy, coding and decoding both very easy for SOS and easy to remember. So that's all for the Morse code today. We'll be looking into new chapters in the next episode. Thank you.